Hi, this is Lakshmi Kantiwari. In this lesson, I am going to show you how you can plot a learning curve and a confusion matrix in a TensorFlow 2.0. Okay, so before we start, I should tell you that I am reusing our previous Jupyter notebook, which you can download from Getting Started TensorFlow 2.0 and the Keras Beginner. The first video which I made on TensorFlow 2.0, you can watch that video here as well. So you need to download this. You need to download this repository. Go ahead and download this repository from here. And once you download it, unzip it, and then start working on this Jupyter notebook. So I have covered that notebook till this line, and in this lesson I'll be working afterward this line. So the Jupyter notebook which you have downloaded, that I was working on MNIST Fashion dataset, and then I have used their ANN networks, and then I had built their ANN model, their artificial neural network, a fully connected artificial neural network. And so you download it, and once you download it and then run it and come to this point, and after that then I'll cover this how you can plot a learning curve and a confusion matrix by using the TensorFlow 2.0. Perfect. So without wasting time, let's go ahead and start this brand new lesson. So in this lesson, we will be plotting a learning curve in a TensorFlow 2.0 and a confusion matrix. So the learning curve will automatically, we will plot a learning curve by using TensorFlow 2.0. But for a confusion matrix, we will use MLExtend library. You can visit this link there, and then you can install this MLExtend library in your computer. Pip install MLExtend. Okay, so although there are some other methods to plot a confusion matrix by using a traditional matplotlib.pyplot, but if you have plotted your confusion matrix, that was a very long code and very much confusing. But in this lesson, I'm going to show you very small code to plot the confusion matrix and the learning curve. So for a learning curve, we have a model which was returned while training our, the previous lesson. So I'm using the same file as I have told you. So we have a model here, okay. And if we type their help and the model, then we will see that what are the parameters which we can apply in a model. And with this help and the model, we can understand that this model returns a history. A history means this model returns the accuracy and the loss for training and the validation for each iteration. So that is what we are going to plot here, a learning curve. And if you see here, somewhere it should see, we should see a history. It returns a model instance, that's okay. But after a bit, do we get somewhere? Perhaps if we apply, that's the summary. If we control and F, and then we, yes. So here it returns a history object. It's a history.history attribute is a record of a training loss value and matrix value at a successive epochs. That's mean in this model while training, we have run it 10 times, and at each of these times it has presented here loss and the accuracy. Now we want to record this loss and the accuracy, and we want to train our model. We want to plot it. So how we can do this? To do this, what we need to do, we again need to get this, the history parameter, return arguments, that we need to type here. History is equal to a model.fit. So let's go ahead and rebuild this model from here, and then it will take a little time. But in meantime, what I'm going to do here, I'm going to pass the batch size. You see here a batch size. I'm going to pass here batch size is equal to the 10. So it will make sure that it will update it will update the weights after calculating, after running on 3 rows of the data. Let's go ahead, and the train it for 10 time, it might take some time. Just wait for, get it trained. So it is almost about to get it trained. Perfect. So the final epoch is running here, and we have achieved around 90 or 91% of the accuracy, and here is a list of the loss. So we have recorded everything in a history object. Let's go ahead and print this history object. Now we don't need to run these things to plot a learning curve, and to do that, what we can do, if we print this history, it says that this is the Keras callback history, and it has another history inside this, and there if we print, it has loss and the accuracy, right? So let's go ahead, import matplotlib first, and to do that we need to do import matplotlib.pyplot as plt. Okay, perfect. Now let's go ahead and plot this. Okay, so I already have ready-made code. I'm just gonna copy this code and paste it here, so that we should not waste much of the time to writing theoretical codes. So here you see, since it has only a loss and the accuracy, we don't have a validation accuracy. So I'm going to just delete these two lines, validation loss and validation accuracy. So in the first line, you see here a history, the accuracy, we are getting this column, this column, and for a loss, history for loss, we are getting here this column. So let's go ahead and run this. Now we should see here a model accuracy, how the accuracy is increasing as we are increasing the epochs, and here we can see how the loss is decreasing. So with this, we can see here loss is still decreasing, and that means we have some scope that we can increase the number of epochs from 10 to, let's say, 20 to increase the accuracy. Our model starts getting overfitting when loss gets increased and the accuracy still gets increases. So in that way we can do. But the another way we can check whether our model is overfitting or not, we can include a validation set. Okay, so for a validation set, what we need to do, we again need to rerun our algorithm by passing here a validation set. If you press here shift and the double tab, you will see here a validation split. In a validation split, what we are going to do here, we are going to just copy it, and we are going to pass here 20%. So out of this training data, there would be 20% of the data which will be used for a validation set. Okay, and let's go ahead and run this model, and then we have made just a little mistake. Since the model was already trained, we need to interrupt the kernel. We need to rerun from here. Let's go ahead and rerun it from here and here. Perfect. So now its accuracy, the accuracy is 82.36% on, and the validation accuracy is 85.37%. So it will run a 10 time. Let's go ahead and wait for some time to complete it. All right. So the final epochs are getting trained, and we are getting accuracy somewhere around 91% in a training set. And if you see in validation accuracy, the validation accuracy is 88%. That's when the training accuracy is more than the validation accuracy, which says that the model is overfitting. And how we can know that the model is overfitting? By seeing a learning curve. With the learning curve, if accuracy of validation set is less and the loss of the validation set is more than the training set, that means we can make sure that we can, get assurance that our model is overfitting. So let's go ahead and see again the history. Now if we see the history, since we have already got the history from here, let's go ahead and delete this. Okay, so here we have already got the history. So let's go ahead and print this history. So once we print this history, and now you see we have got a validation loss and a validation accuracy as well. So let's go ahead and plot a validation accuracy with the model accuracy and validation loss with the model loss. So how we can do this? We can do that with the plt.plot the history, and there we need a val accuracy, and similarly here we need plt.plot the history, so the history, and there we have a validation loss. Okay, so we have got a validation accuracy and the validation loss. Let's go ahead and run this cell. Once you run this cell, now you can see here the training set accuracy is increasing, but the validation, or you can see the test, actually it's not a test, but in fact it's a validation. Okay, perfect. So now you see in a validation set how it is the accuracy is the decreasing and increasing kind of thing. So this says that our model is getting overfitted, and you see here the validation loss started it decreasing, but after some point, after second epoch, it has started increasing. So this says that our model is getting overfitted, which we can also prove with the accuracy which we have got in our training set and the validation set. So if there is accuracy different, that's mean if validation set accuracy is less than the training accuracy, it says that our model is getting overfitted. Okay, so let's go ahead now get the Y prediction, and let's go ahead and get the Y prediction with this model which we already have here, this code, and let's go ahead and run this Y prediction. So we have here Y prediction, and the accuracy on the test set we are going to get 87.71%, and the Y prediction value is this one. And now what we are going to do, now we are going to plot a confusion matrix. Since we have got Y pred and Y test is the true value of Y and the predicted value of Y is Y pred. Let's go ahead and come here and write here plot confusion matrix. Okay, so for confusion matrix, what we can do, for a confusion matrix we actually need MLExtend library, which you can install by calling you see here, by calling a pip install MLExtend. And once you get it installed, then what you can do, you can import plot confusion matrix from MLExtend. You can write here MLExtend dot plotting import plot confusion matrix. Oh, it says that I don't have MLExtend as well. So what I can do, I can install the MLExtend from here itself. So I can just write here pip install MLExtend. So it will install MLExtend, then we can run this cell. And while it is installing, let's go ahead and import confusion matrix from sklearn matrix. So it is already installed. Yeah, the MLExtend is installed there. Let's go ahead and import confusion matrix from MLExtend matrix. Import the confusion matrix. Perfect. Now let's go ahead and get a confusion matrix in a mat variable, and there we need to pass here a true value, that is Y test, and the predicted value, that is Y pred. And then we are going to get here inside a figure and the axis object. Okay, so although I don't think we need a figure and the axis object, let's go ahead and do with just direct plot confusion matrix. Inside the confusion matrix, we need to press shift and the double tab. Now you can see it asks first confusion matrix and then other parameters. So the first we need confusion matrix is equal to the mat, and let's go ahead and run this. Once you run this, you will see here a confusion matrix with the different classes. So there are 10 classes in this Python MNIST dataset, and this is a predicted label and this is a true label. Now let's go ahead and see how we can increase the font size and the figure size of this confusion matrix, which we can do here by just passing a parameter in a fixed size. There I'm going to pass a 10 cross 10. Let's go ahead and run this. Now we have got a 10 cross 10 matrix. Although I don't want 10 cross 10. Let's go ahead and get in 8 cross 8. Now this is kind of okay. Perfect. Now you know here, so these classes are kind of the categorical classes 0, 1, 2, 3. Now let's go ahead and print here classes name. And if you remember, if you in the previous video, the first video, there we have a classes name. Okay, so these classes name we want to print here. So let's go ahead and pass that parameter a classes name. So here we have classes names is equal to a classes names, and let's go ahead and run this, and here we have got. So the top here, the predicted label and the true label. So in the true label, the top 816 time has been classified the true, but you know, it has been also predicted 13 times, but the pullover actually, the pullover has been predicted 13 times as a top, and the dress has been predicted 17 times as a top. So this is how we can the plot a confusion matrix. Now let's go ahead and see if we want to change I mean, let's go ahead and see if you want to print of the probability of actually the accuracy of each classes, then how you can do. To do that, the press here shift and double tap, and then you will see here so the so normed. Okay, so so normed is false and we want to make it true. So if we make it true, then we can also get the accuracy of each of these classes, how accurately those classes has been predicted. Like a trouser, the accuracy for a trouser is 98%. Okay, so this is how we can get the individual accuracy for each classes by seeing a confusion matrix. Now the question is how we can change the fonts and the font type and the weights and the size of these fonts. To do that, we can first create a dictionary of a font. Let's go ahead and create that dictionary, and in that dictionary the first one is family, that's in the font family, and in the font family we are going to type here Times New Roman. We are going to convert it into the Times New Roman, and the weight of fonts, which the font which we are going to use, the weight we are going to use here bold, and then finally the size of the font, I'm gonna put it let's say the 18 or a 16. Okay, so now we are going to call here the matplotlib, but before calling the matplotlib we need to import matplotlib actually. Okay, so let's go ahead and call here the matplotlib.rc. okay, and there we are going to pass the parameter a plt. Okay, sorry, pass a parameter a font, and inside a font I'm gonna pass the argument. Okay, the extra argument is a font which I have created here. Let's go ahead and run this, and you will see here it has been changed into Times New Roman with a bold, but the bold is not looking good. So then what we can do, we can just remove this bold, Otherwise we can keep this and we can just write here normal. The normal is not working. Just go ahead and remove that and print it. Somehow it's not working. To do that, what we can do, we can just first comment these lines, and now we should have the original. Since it has already the stored it into the computer, that's why it might be not working. To do that, what we can do, we can go ahead from here. Still it's not working. Let's go ahead and copy it and paste it into another cell and see if it is working there. No, it has set. Actually we need to it has actually set this the default parameter, so we need to reset that. To reset that, what we can do, we can reduce the size. Let's go ahead, first increase its dimension 12 cross 12, and then we can reduce the size with 2, and then we can make it false. Let's go ahead and run this. So with this, now you can see here at the top, trouser, etc., is the being printed here. Okay, so this is how you can print a confusion matrix, and this is how you can plot a learning curve using a TensorFlow 2.0. So this is all about in this lesson. Thank you so much for watching this video. Please don't forget to like and subscribe this channel. Bye bye. Have a nice day.